So here we're given this equation, which is actually a quadratic, is just hidden with the negative exponent. So you have two options. You can either directly turn it into a quadratic by saying y to the minus 1 is z. If you replace that here, y to the minus 2 would be z squared. So you get your standard quadratic. So this is the fastest way to do it. I'll do another way as well, but this would give you immediately a quadratic. We can factor this. It's going to be 5 times 3 is 15. So it's going to be z plus 5, z minus 3 equal to 0. So two solutions would be z is either minus 5 or z is 3. Now, z itself is y to the minus 1. So we have two values, and y to the minus 1 is 1 over y. So y is either 1/3, and this one will tell us that y is minus 1/5. The way the question is phrased, which is the following, could be the value of y. So they haven't given us this. So the answer is minus 1/5. So that's one approach. Now, if you don't recognize that it is a quadratic and doing this substitution, the other approach would be to rewrite y minus 2 is 1 over y squared and y to the minus 1 as 1 over y, and replace them. So 1 over y squared plus 2 over y minus 15 is 0. Then you multiply it throughout by y squared. Each term has to be multiplied. This side remains 0. So it's 1 plus 2y minus 15y squared. I'm actually going to multiply both sides by minus because I like to have a positive coefficient. And that becomes this. So this is our quadratic. And we have to factor it. This is a little bit harder when you have two numbers like this. You have to split the middle number, and so that the product comes out to be minus 5. Yep. And then we factor a 5y, factor a 1 here, and then you pull out 3y minus 1. And then again, you'll see, you equate these two terms to 0. This one will give us 3y minus 1 is 0, or y is 1/3. And then that's going to give us the minus 1/5, which is what they've chosen to write. So in either case, the answer is C.